This is a chair. But you knew that already. More importantly, how did you know that already? If you were to create a set of rules in your mind that defined how you think about a chair, what would those rules be? How many rules would you have? Computers, on the other hand, aren't quite as good as us as determining whether that is a chair or not. Over our lifetimes, we've accumulated billions of data points that tell us the nuance of whether something is a chair or is not a chair. It's important for AI to have that same level of data for it to be able to make good decisions. Let's find out why. To create a set of rules in your mind that define how you think about a chair, what would those rules be? Most people say things like, has 4 legs, or something you can sit on, or has a base and a flat surface attached to it. But think about the rules that you came up with. Look at these images of chairs and tell me, how many of your rules would have worked? This example is actually one of the most commonly used examples to illustrate the limitations of rule-based models and the benefits of having a machine learning model that might be able to expand outside of those rules when they just simply won't be able to address all of the use cases for something such as top-down views of chairs or uniquely shaped chairs like we saw. Now, this also illustrates the need, though, for machine learning models to have a vast amount of data to cover the types of use cases that we need. Now, you might say that you don't need to cover all of the types of chairs in our example, but certainly you want to cover most of them. I want to show you a tool that I use, which is my absolute favorite tool, to demonstrate why it's important to have representative data and a lot of it while training a machine learning model. Take a look. This is an extremely fun demo created by Teachable Machine by Google. And in this example, you're going to actually train a machine learning model in real time by taking pictures of yourselves raising your hand. The goal of this machine learning model is to recognize when you're actually raising your hand or when you're not raising your hand. So let's take a look and dive in and do it ourselves. So I'm going to go ahead and click Start, and it's going to take pictures of me with my hand raised up or down. All right, and my camera's back on. So let's first start by taking pictures of myself with my hand up. So I'm going to hold to record and take lots of pictures here. I'm going to have my hand up and down and kind of all over the place, maybe move my body just a little bit, and we'll pause there. We've got 257 images now of my hand up, which isn't actually that many when you look at machine learning models in the amount of data that they need, but this will suffice for this fantastic little tool. So let's move on to the next chunk of this. Now we're going to record pictures of myself with my hand down. So I'm going to hit hold to record, and it's taking a bunch of pictures of me. I'm going to move around the screen so it captures me in different positions. My hand did pop into frame there. I wonder how it will calculate that into its decision process. Now I'm going to go ahead and hit next. You can see here are many different images of when my hand is up and many different images of my hand down. All I have to do now is hit train model, and it's going to create a machine learning model that is designed to recognize in real time whether or not my hand is raised or it is not. Let's take a look here. This will take just a minute. You can see it processing. It's amazing how fast it's doing this. Fantastic. So now we can try it out. You can see here that there's a bar at the top that says hand up and a bar at the bottom that says hand down. These are the confidence intervals, essentially, that indicate whether or not this model believes that my hand is raised or not raised. Right now, the bar is full on hand down because it's very confident that my hand is down. If I move around a little bit, because I got representative photos of myself moving around, it's not necessarily confused if I just move my body. Now, if I put my hand up, it has now recognized by indicating in this bar that my hand is raised. Now, if I move my hand around or down, you can see it starts to become a little less confident. It's a little less sure whether my hand's up or not. But when I put it up just like this, which is probably the vast majority of the images that I took, it is very confident that my hand is raised. Now, note that I didn't take any pictures with my other hand up. Let's see how it performs if I raise my other hand. Okay. Actually not too bad in this circumstance, probably because I moved my hand around. If I move it a little bit more in front of my face, I didn't get a whole lot of image samples where it looks like this. As human beings, we would currently say my hand is up, but the model does not believe that my hand is up. I clearly didn't get any images of my hand being up in around this position because it's not confident at all. And as you can see, as I move higher up, its confidence starts to wane a little bit too. So this is all a great example of why you need representative data. If I had taken more pictures with my right hand up, I would have covered a lot more of the edge cases so that it could detect whether or not my right hand is up just as well as it detects and as confidently, like this, as my left hand. But I didn't take those pictures, so I didn't have a fully representative data set. So we have to decide as data scientists, product managers, business people, just the extent of the data that we need to cover together to make sure that we're meeting all of these cases. I recommend using this tool with your teams to show just how important data is to the process of training a model.
Pretty cool tool, huh? What do you think, Thomas Bayes? Is that pretty cool?
Fantastic technology there, Daniel. But do you think that they could see that your feet couldn't touch the ground when you were in that chair?
Short joke. Nice. Well, anyway, I'd love to hear from you. Is there a way that you use analogies or different tools to explain the importance of data in your field? Did you come up with any interesting rules, or do you even think that a rule-based engine approach to defining a chair or not a chair could ever work? Let me know in the comments. I'd love to read them.